We've just gone through some nice mechanics here with the language, looking at that idea that errors have to provide context. We talked about the error itself being the context. We talked about error variables being the context. We talked about using custom error types where the type itself is the context, or even better, when we can use that interface type and make the behavior the context. I also showed you a quick bug where we've got to make sure that all of our functions are returning the error interface for the error, using the interface value and not the custom error types themselves. But one thing I also want to share is a design pattern that can really help minimize problems in code. And that's the idea of handling an error. Now, handling an error is a complex thing, and you've got to have some rules around it. And for me, handling an error is going to mean three things, basically. It means that the error is going to stop there with the code that's handling it, which means the error doesn't get propagated anymore. Either we're going to recover or we're going to shut down. Two, it means that that error is going to get logged. So now that error has to be logged there, and it has to be logged with the full context, okay, the full context. And at that point now, we've got to also make sure that the code that we're deciding is doing all this can log. When we get into package-oriented design, we're going to talk about policies about who can log and who can't log, who can shut down apps, who can't shut down apps. But error handling is going to be around the idea that the error stops here, we're going to log that error, and then we're going to make that decision on whether we can recover or shut down. And I see a lot of inconsistency in code bases here when it comes to handling an error. So one of the nice things here is that Dave Cheney wrote a package, his own errors package, and I want to show you how to use it because I think it really lends itself nicely to dealing with this idea of how to handle errors. So let's go ahead and we'll take a look at some code here. You can see up front in this code on line 14, I've gone ahead on line 14 and defined a custom error type called app error. It has that state field, and we've implementing the error interface using pointer semantics on line 19. Now, the main function's making function calls and first call into second call, and I really want to get over to the third call because this is at the end of the call chain. And what we can see here is that when we get to third call is failing, and it's returning that concrete error value, app error, with a value of 99. So what we can do is imagine right now that this is the error value. It's app error, there it is, and it has a 99 in it. This is the root error value. This is the cause of everything that's going on. And this function obviously is not going to handle the error because it's producing the error, and it's going to return it back up the call stack. Okay, so what happens next? Well, that third call function was executed by the second call function. So on line 58, we have the second implementation of second call. It takes an integer as a parameter. And you can see here that third call was executed on line 59. We get back the error value. We say, is there a concrete value stored inside the error value, right? And the reality is that it is, because when we called third call, it didn't bring back the concrete value, right? It brought it back through the error interface. So we know, right, that there's that concrete value stored inside. That's going to be true. But this is the key now on line 60, because what we're going to say on line 59 is, okay, there is an error, but are we going to handle it? Remember, handling it means that it stops here. It means that we're going to log it, and then we're going to make a decision around recovery or shutdown. But this code is saying, you know what, I'm not going to handle the error. And that's great. You're going to either decide you are or you are not. And if you're not going to handle the error, then you have one choice. And that is to wrap all the context you need and to pass it back up the call stack. What we're trying to do is the idea of logging the same error over and over and over again in the logs just to get that call stack information and other context, right? That just pollutes the logs, and it's something we really want to avoid. So the whole idea of this wrap function that we're getting from Dave Cheney's errors package is that we're going to wrap this error around another error. All right, we're going to wrap it around another error, and then we're going to have our call context. We're going to get that for free. We're going to know what line of code we're on, all that good stuff. And then we're going to have our user context. That's that string that you see on line 60. And now when there's an error, we're going to have this stuff in our logs, and we should be able to fix the problem between the mental model of our code base, between this logging and the context. So we just wrapped that error around a bunch of stuff. And then what we do is we return that error back up the call stack. Now I just returned that back up the call stack to first call. And we go through the same pattern. First call called second call. Did second call get back an error? It did. We did get a concrete value stored inside the error interface. And now we do another wrap. In this case, I'm wrapping the parameter or the value that we passed into the call. So here we are again. We're wrapping it again. There it is. We got more context coming in, both call and user context. And we've got these layers of context being wrapped together. But eventually somebody's got to handle the call or handle the error. And you're going to see that work right here in main. So here's the call to first call. We get back the error value. Was there a concrete value stored inside the error interface after the call? The answer is yes, there is. And what's nice is this cause function. So Dave added a function called cause. And what the cause function does is it allows us to unwind all of this wrapping and get this error value back out. So that cause function is getting us back the error value that we started with from the beginning. And that lets us use all of those mechanics that I already taught you, right? You can see here that we're asking, give me the root or cause error value for this. And then we do that type assertion that I showed you already. And we can ask, was the root cause an app error? And we can do all of the mechanics that I showed you up to this point. But what's really nice is not only can we do all of those error mechanics that we talked about, type is context, behavior is context, but that error, this error value that we're wrapping everything around, does implement the ability to do some custom formatting using the %v and %+v formatters on both fumped and log. And what that's going to do is give us that stack trace. Now, if we use +v, we're going to get the full stack trace from every wrapping position. Or if we just use v, we're going to get the custom context. And this is, again, something that you're going to be using during development to validate that all this error handling is working right, that all of our logging is working right. So why don't we go ahead and build this code so you can see what I'm talking about here. I'm already moved into here. Let's see. Yep, we're already in example 6. I'm going to build this, and I'm going to run it. And what you see really quickly here is that we got that custom app error 99. You see that we've got the full stack trace right here. There it is. And we've got the stack trace from those different wrapping calls, right? So here we've got the full stack trace. Second call had called third call, right? There's the second call, first call main. We know what lines of code we were on and all of that good stuff. If I make this a little small, it should be a little easier to see that. And then we have this first call, second call. We pass the value of 10 at that point when we made that call to second call, and we see the stack trace from that point of view. So we've got the stack trace from different points of view in the call chain. And if we don't want that level of detail, we can even just pull out just the user level context and still see everything. This is a brilliant pattern, and it's going to keep your code simple, because now as a developer on the team, you basically say, hey, is there an error? Oh yeah, there was an error. Am I handling the error? No, I'm not handling the error. We just wrap and bring that error back up. And the code will be very clean for that. Hey, I am handling the error, no problem. Now I know I have to log it. Now I know I have to make a decision. I know that the error stops with me. Am I going to be able to recover, or do we have to shut down? And in a code review, we can also validate that this design philosophy and these guidelines are being followed. So this is a recommendation that I give all of the teams that I'm training all the time. Let's use this wrapping pattern for our errors, and we'll keep those code bases clean. And then during development, during unit testing, any testing you're doing, validate that you have enough context in the logs. And if not, we can enhance those strings on those wrap calls to get everything that we need.